These are some more examples of using my metal lathe adapted for ornamental turning. In this case, it is a fly cutter oriented in a horizontal position. The cutter itself is a 1/8 inch carbide cutter with a 60-degree tip on it. The radius of the cutting head is 0.8 inches. This one is speeded up 4 times, as once again I let Corn Lathe set the speeds and feeds. This is a pattern that will ultimately appear like fishnet. I was adjusting the light, trying to get more contrast so you could see the pattern develop a little bit better. This is one of Bill Loom's examples in Corn Lathe. Many of his examples are cut on 2-inch diameter stock. So this is a 2-inch poplar dowel from the hardware store that I commonly use for experimental purposes to develop patterns and experiment with different depths and cutters. This pattern has been phased 180 degrees. It is quite easy to arrange that within the software. And it is a simple sine wave pattern. I'll skip ahead shortly to a more developed version of the pattern. And this one is running at only 2 times speed. This entire pattern cutting took roughly 40 minutes. There are very few fuzzies on this one, even though this is just poplar. It is helpful to be cutting in the direction of the grain. This next pattern is called honeycomb. And I apologize for the orientation of the camera. I was thinking more of the shot than of the orientation. Here's a look at what the stepper motors are doing in the front of the machine. This honeycomb pattern is very similar to the fishnet pattern underneath it, except the cutter is somewhat shorter. The radius of this 1/8 inch carbide cutter is only 0.5 of an inch. You may notice that the cuts look rather fuzzy compared to the last one, and that's because when I changed the bit I put it in backwards. This is a little further on in the cutting process, once again speeded up 2 times, and you can see that honeycomb pattern developing nicely. The fly cutter is a remarkably simple bit of equipment. This one I turned on this same metal lathe and drilled an 1/8 inch hole for the bit and a suitable hole for some grub screws to hold it in place. It's turning at roughly 4,000 RPM. This last example is a slot cutting bit, 3/16 inch wide, doing a basket pattern, and this is in real time. I had to adjust the light a couple of times to get the pattern to show up, but as it develops, it becomes quite obvious. There's a little bit of tear out, but because this is popular, this is not surprising. I left this running for the full length of the cut so you can appreciate how quickly a computer-controlled lathe can accomplish this task. This is another example in Bill Loomis's corn lathe program. This is a very commonly seen pattern in the ornamental turning world, where there is a cut pattern based on a simple sign that's overlapped 180 degrees, or half a pattern. I'm utilizing the G-code nearly directly from corn lathe. I just have to do a text edit substituting C with A to make the control card happy. At present, this is being run under Mach 3. This will eventually be able to be run under gerbil using gerbil glue. As you see, this pattern is developing really quite quickly. The 800-watt spindle I'm using has no trouble at all with these shallow cuts. Using a spindle directly like this, I can use a variety of commonly available rotor bits like this slot cutter. Packs of these come in widths ranging from a 1/16 up to a 1/4 inch. It is very easy within the software to change this from a 2-inch diameter piece to 4 or 5 or 6 inches, and then previewing the appearance of a larger piece in the visualization part of corn lathe. If necessary, the frequency of the sign pattern can be increased or decreased to achieve the result that's wanted. I dust this off with a nylon brush to get rid of some of the fuzzies so you can see that developing a little bit better. I hope you enjoyed this short presentation. Thank you for watching.